Welcome. Today is day 3 of the Pre-MBA Preparation series on this channel. In this series, I learn difficult MBA concepts, make notes on them, and share them with you every single day till I join my B school. Now, if you're on the same boat as me, I urge you to subscribe to the channel and let's prepare for MBA together. Take this as a friend of yours, a buddy of yours who's preparing, who's on the same stage as you, who's preparing for his pre-MBA studies, and he's sharing with you whatever he learns every day along with the notes. That's all it is. All right. So what have we already covered? In the past 2 days, we have already covered 3 lectures of this particular course, that is Business Analytics for Problem Solving. And this is an Ahmedabad course. If you have not yet started, go to day 1 and start it. The link is in the description for the course as well. Okay. And also the notes as well, if you want to access that. Okay, today we are going to start with lecture 4. I've already finished half of this lecture, not the full, because this lecture was particularly heavy on concepts and various things that I have to recall from my class 10, class 11 studies. So all of that I've put it down in the notes. So you don't have to go back and start researching. You can just watch this video and get it done for yourself. Okay. So this lecture is about more statistics to make me an expert. It is taught by Professor Tathagat Bandyopadhyay, and today's date is 29th of April 2025. Let's get started. He starts with what we've already learned in the last lecture, but a little more out of it. That is summarizing qualitative data. How do we do that? We have already seen this, that we do that using frequency distribution. Data summarization is done using frequency distribution. And the second thing over here is relative frequency. This is something new, so I'll explain this. What he taught me is that relative frequency is basically a ratio. Okay, what is the ratio between? It's basically the frequency of a particular category upon the frequency of all the categories together. Okay, so that's a ratio, and this ratio is called relative frequency. The same thing, but in a percentage format, we will call it percentage frequency. All right, and then there's the two kinds of graphs or charts that we use, that is bar graph and pie chart. That's about summarizing qualitative data. Now about summarizing quantitative data. How do we do that? Frequency distribution, but grouped, or interval basis frequency distribution, as we have seen. Second is relative or percentage, as we've just discussed, but again grouped or interval based frequency distribution. Third is a dot plot or a scattered plot. These are plots that are used. And fourth is histogram, which we've already talked about in the last lecture. Now comes new things. The first thing that we're going to talk about is the use or the role of standard deviation. Let's see. Standard deviation can show us the uncertainty that is associated with a particular time series data. We've already seen what is time series data. Okay, so if you don't remember these concepts, go back and watch those. Example of this is volatility of stocks. So volatility of stocks is risky. How do we look at that? How do we see which stock is risky? So let us consider there are two companies. One is company A, the other is company B. Both have stock lines in a time series. Now, if we see that the standard deviation of a particular company's stocks is more, what that indicates to us is that that particular company's stocks is more volatile, and hence it is more risky. Understood? The second example is, for example, we look at per capita income of countries. So now generally what we look at is the average per capita income of a country, but that doesn't paint the whole story, because average can be like, there's a person who's really poor who earns very less, and there are people who are really rich, and the average between them comes out to be somewhere in the middle. The problem here is we are not able to understand how expansive is this whole data set. We can only understand that through standard deviation. All right. So in essence, standard deviation is a measurement of the variability of values. Makes sense. The next thing that we are going to learn is association versus correlation. Now, what is this? Let's suppose there are two variables, X and Y. If Y changes in a linear manner along with X, then we can call it a correlation. However, if Y changes in a non-linear manner with X, so for example, X goes up, but Y over here goes up and down as X goes up, that would mean that it's an association, but it's not a correlation. Make sense? Now let's understand the combination of scatter plots, correlation, and accuracy together. How does it work together? So suppose we have a scatter plot. We make a scatter plot. There's a graph like this. You can see it in the notes. There are different points that have been put on the scatter plot. Now, if these points, the more cohesive they are, that is, the more they are in closer to the line that you see in between, that would mean the correlation is stronger, which would mean that the prediction that we make will be stronger for the next point that we plot on this graph. Make sense? If on the other hand, the dots are far away from each other, that means the trend line is blurry and we can't probably say with a lot of probability or with a lot of confidence that the next particular point will be somewhere close to the line. We can't say that when the correlation is weak. So prediction probability or the prediction confidence depends on how good the correlation is. We'll look at this in a more detailed manner later in this video only. Let's look at this extra note as well. The central line through scatter plots is called a regression line. Again, Mr. Tathagat, our professor, he said that we'll look at this later in the lectures, so I'm not concentrating much on it right now. Let's go to the basic terms of statistics. This is extremely important. The first thing is mean. The mean of a data set is the average of all the data values. So basically all the data values divided by the total number of data values. So that is the mean. We all know about it, so we won't go much into it, but it's basically known as the average or the mean. The second is median. The median is the middle value. The middle value of a data set is basically a value above which there's 50% data and below which there's 50% data. Make sense? So you have to basically put a data set in ascending order, above which there's 50%, below which there's 50%. That's median. Mode is basically the mode of a data set is the most frequently occurring value inside a data set. All right. So in industry purposes, generally median and mean is used because it's easier. With mode, sometimes the data becomes too difficult to work with when it comes to mode. How do you find a frequency for every kind of data? It's very difficult if you see the examples, but I'll not go into it right now. We might see it later. So that's about mean, median, and mode. Let's go to percentile. Now, what's a percentile? You should be familiar with this because we are just given the CAT exam and our scores come to us as a percentile. So let's understand the concept. The pth percentile of a data is a value such that p% of the items take on this value or less than this value, and 100 minus p% of these items take on a value greater than the given value. That's a percentile for you. How do we calculate percentiles? There are 4 steps to it. Let's look at it. For the first one is arrange the data in an ascending order. We have to do this as the same way like we do for median. The second is compute the index I, that is the position of the pth percentile. How do we compute it? It's the formula I equals to p divided by 100 multiplied by n, where n is the number of values in the data set. Third is if I is not an integer, round up. The pth percentile is the value in the ith position. And fourth is if I is an integer, the pth percentile is the average of values in position I and I plus 1. Now in this totally makes sense. Please either pause this video or try to internalize this when you do this yourself. This particular calculation is done where you will basically understand this if you just spend a little bit of time understanding or looking at it how it really works. All right. Now let's go to quartiles. Quartiles are specific percentiles, that is 25th percentile is called the first quartile, 50th percentile called the second quartile, 75th percentile is called the third quartile. You would know this if you have watched a lot of or you've looked at the B school PDFs where they show how many people or what salary basically can a 25th percentile or a 50th percentile student expect. They have put those values. So check out some of the B school brochures and you will see how much you can get as salary in terms of percentiles as well, in terms of quartiles as well. Now let's go to range. Range is basically very simple. It's the largest value in the data set minus or subtracting from that the smallest value of the data set. So that's called the range. In quartile range is something which is very interesting. I had never heard of this before, but it's basically the difference between the third quartile and the first quartile, which basically means it is the range for the middle 50% of the data. What this generally does is it is used for overcoming the sensitivity of extreme values. So below there are some outliers. Above the data set, there's some outliers. In the middle is basically the range of values which we can actually consider for making a reliable prediction. And that is where in quartile range is used. Now going to standard deviation, but the maths of it. We already looked at the concept of standard deviation, but now let's go into the maths of it. Standard deviation of a data set is the positive square root of variance. What is variance? We'll look at it just after this. The second is it is measured in same units as the data. So it becomes very easy to use for us because things like mean, things like standard deviation, these are things that are in the same units as the data. So we can understand, okay, for example, we have a 5 rupee note. So the value of this note can go up by 1 rupee or go down by minus 1 rupee. That is what it means. So it's very easy to understand. If we say that we have 100 kgs, we're predicting the weight of something to be 100 kgs, and it's a plus minus 1 kg factor, then we know that it's plus minus 1 kg. It's easy to understand. Okay, I think you got it. The third thing is, if the data set is a sample, the standard deviation is denoted as S equals to root of S squared. That is to say that it's a positive value. And if the data set is a population, the standard deviation is denoted by sigma, as we've already discussed, or we did not discuss. Maybe we have learned this before, that is why we are saying this. Anyways, for populations, we say it's sigma. For normal data sets, we say it's S. Let's go to variance. The variance is a measure of variability that utilizes all data in the dataset. It is based on the difference between the value of each observation, that is xi, where I can change from 1 to the n number of datasets, and the mean, that is x for a sample and mu for a population. Again, this is something very interesting which I found. A lot of these concepts have different symbols for a normal dataset and a population, which I think is because a lot of people use statistics for population basis problems, so they have a different complete symbol for use of population. Now let's come to the formula for this. Variance formula is S squared equals to sigma. That is, this is not sigma. This is, we say this as sigma as well, but this is basically summation of xi minus x whole squared and divided by n minus 1. This is not x, so that's my handwriting, I'm sorry, but n minus 1, where n is total number of values. And standard deviation is S. Okay, let's go to covariance. Covariance is a measure of the linear association between two variables. Now, if we have positive values as covariance, then we can say it's a positive relation. If you have negative values, we can say it's a negative relation. All right. Now let's go to the type of correlations. As I said that we'll look at this further in detail. So this is the types of correlation in scatter plots. Let's say that we have the first kind of a graph where there's points everywhere scattered. In this case, we can say there's no correlation and the correlation coefficient is 0. If indeed we have plots where the points are in a positive direction or a positive curve, then we can say it's a positive correlation. But in this case, we can say that it's weak. The other case, we can also say that if it's a positive correlation, but the points are more cohesive in nature, that is more together, then we can say it's a strong correlation and a strong positive correlation. You can see the vice versa of it over here as well. There's a negative correlation which is weak, where the points are more scattered, and there's a negative correlation which is strong, where the points are less scattered or it's more cohesive in nature. Then there's also these two, which is positive perfect correlation, that is all the points are in a single line, and here we can say that the correlation coefficient is +1. And the other case is negative perfect correlation, so correlation coefficient is -1. So all the dots in a perfect line, but in a negative sense. Okay. And then the final thing for today is one important aspect of statistical theory is the measure of uncertainty. So this is what he was explaining in the middle of the lecture, that uncertainty is something that is very important that we account for it, because none of the models or none of the statistical data that we use are perfect, and there's always a measure of uncertainty. He explained this with a very nice example actually. So for example, there's a population of 500 people, okay, and within that there are 450 non-smokers and 50 smokers. Now for example, an outside agency comes, an independent agency comes, and they say that we want to understand how many people in this population are smokers. Now at random, they pick up 50 people out of the population to just have a small sample space and look at an estimate of how many people are smokers. Now by luck or by bad luck, there were all of the 50 people who were smokers inside that 500 people population place. All of the 50 people who were smokers were picked up. Okay, so what essentially we would say is, what that independent agency would say is that all of the people in this population are almost smokers. But that's not true, right? Hence, we have to always show that there's an uncertainty inside it. And we can say that there's 95% confident, we are 95% confident that this is our final statistical inference, but then there's also 5% probability that we are wrong. And that is extremely important for us to appreciate and also measure using statistical theory. How do we do that? Again, they have to teach me, only then we can understand. Okay, that's all for today, and we'll start tomorrow from measures of relative location and detecting outliers. And this is in the middle of the lecture 4. So if you're with me till now, complete this till the middle of lecture 4 and you will be at pace with me. Tomorrow we'll complete the rest of the lecture 4 and possibly more if the rest of lecture 4 is easy. I don't know. But that's all for today's video. I'll meet you tomorrow. Namaskaram. Bye bye.